which is system-based process mining. And this is where we're actually going to be grabbing the data from our log files so we can then generate our map automatically. That's what we're trying to do with process mining. We're trying to do it automatically. We have all our system. We have our ERP system. We have our CRM system, our HR system, right? And what we need to do, we need to tag those columns. We need to tag those columns that come from those systems. Say, hey, this is a process ID. This is the description of the task. This is the start date, the end date. So you can see here what you have to do. 1, upload the data source. 2, upload a reference model if you want to compare it. 3, map the columns. And 4, visualize the process. Click and it will visualize it. Let me show you what it actually looks like. Okay. So inside process mining, like I said here, you have 1, 2, 3, 4. Upload a reference model. A reference model is a defined model that you already have created, for example, BlueX Live or another tool. They say, hey, this is how what the ideal model would look like. And then let's compare the actual data against that reference model, right? And then you map those columns, right? You can see here, request ID and activity, start date and end date. So you need to map it. You need to tell the system what those columns are. And then you press the magic button, visualize your process. And once you press that magic button, it's going to process those hundreds and thousands of rows of log file data, and then automatically generates the whole process map for you. For example, here, when we look at frequency or rework or average duration or cost, we can look at the process from different dimensions. This is frequency. How often does it happen? You can see here that there are 116,000 instances of requests created. And then of those 100,000, 47,000 will go to the next step, network service closure, right? So the darker the box, the more often that activity occurs. This one 160,000, this one 7,000. And here are the numbers that go from this activity to the next one, and here 41,000 from this to that one. So right now we're just looking at the volume, but you can also look at it from different perspectives, such as costs, or such as time as well. And the thicker the line, the more the width of it, the more activities or the longer the duration. For example, when we look at the duration view, we can see here that typically it takes 7 hours for that activity. You can see here a thick line coming from there, meaning that this particular transition from this to the next one takes a long time, right? And the darker the box, the longer it takes as well. So that allows us to very quickly see where are the bottlenecks in my process. If you do it visually, you can immediately see what's going on, because this raw data is, like I said, is hundreds of thousands rows of database files or SAP files, right? And that's very difficult to see what's going on. All right. If I have any KPIs that I want to adhere to, I can set my KPI settings over here. And then when I have a KPI palette view, I immediately can see, hey, the green ones fall within the KPI. Anything other color, orange or red, it's outside. You can see here, this takes 23 hours, 18 hours, and this one 52 hours. I guess that one is longer than expected. So you can immediately see any outliers compared to your set KPIs. Yeah. And when you have the animation turned on, you can actually see the actual flow. It replays those activities that actually has happened over time. So you can kind of see the flow of activities moving from one task to another task. That's pretty cool to see. So you can see the volume and the speed of those activities animated in this particular view. And this is all real data. These are real instances that are happening when you replay the history of those of that particular process. All right, and then the whole point of it is to give you insight in, like, hey, this is where we can improve things. This is where things are slow, and this is where we could, benefit from automation. Now you can also have a BPMN view of your process map. So BPMN is a notation standard. It's a very strict way of actually, drawing things. And you can see here a BPMN representation of that process that we have just discovered from our log file data as well. Now, the cool thing about this particular diagram is you can do rules discovery. This is very unique to our product. So you can actually figure out what were the rules that make it go from one activity to another activity. So you can see here the 4 decision activities, right? Exclusive gateways. And you can see how many went in and how many went out. And you can see the actual rule. It went to that activity because of the state of certain values, were like a resource is not an SA60. That was actually discovered by the tool as a rule, whether it went from one activity to another activity, right? So that's how you can actually figure out and discover the rules inside your model, because you can look at the data to say, hey, if it was above 100, it always goes there. If it was below 100, it always went that way. That's how we can figure things out. Now, if we delve a little bit deeper into the dashboard, we can look at the individual activities that we have discovered. We can look at it from a KPI view as well in this type of diagram. We can drill down into the performance, and we can see the performance of the charts over time. Now, one of the things that we want to do is, hey, maybe there is a way to actually improve these things. Maybe there are some really good candidates for automation, RPA candidates, right? These type of activities that require a lot of human activities, a lot of human resources are involved in those activities, right? And there might be a way to actually improve the speed of those activities by automating them. So we're actually asking the system to identify RPA candidates for us inside the process. And this one is a great one, network service closure. The system has identified that as being a good candidate for RPA. So you can set the definitions for your simulation. You can set the boundaries for the simulation over there as well to figure out, what would be a good threshold for something to be a good RPA activity. All right. So let's create a new scenario, because we want to see what the impact of automation would be on our process. How much money would we save if we had more automation in there, right? Now, the reason why I want to know this is I need to justify my IT projects. We always justify our IT projects, right? What is the ROI? How much money do I put in? How much money do I get back, right? And this will help you simulate, the benefits of automation, so then you can go back to your management and say, hey, I have a data-driven approach to my automation projects, where I've identified suitable projects, and I've also identified how much money I could potentially save if I automate them. So this will help you justify your projects to your management. Okay, so I'm running this and setting up this particular simulation over here, where I'm going to be saying, hey, I want to replace a certain amount of activities by automation activities. So I have here my FTEs, my staff availability, the amount of working hours or working time, and I can change them. I can change the amount of staff that I have and replace it by an automated activity, and then simulate how much I could potentially save in terms of throughput and in terms of the actual cost. Okay, so I have here a certain amount of staff, a certain amount of service time, and then working time. So let's say we're adding some robots here. So we're adding, for example, a few bots, like 90% bots, 2 robots. And then we can run the simulation to see what would be the difference between that scenario and our existing situation. So now it's going to run the simulation. Okay, so once it's finished running the simulation, it's going to show me the results side by side. It's going to show me scenario A. It's going to show me scenario B, how much money it costs for scenario A and B, and the total cost of running that case. So this immediately will help me, like I said, justify my project, right? Why are we doing this? Why are we doing this if we're not saving any money or FTEs? So this simulation will help you actually calculate the potential benefits before you start doing the actual IT project. So you're taking out the guesswork of the ROI of your IT projects. Okay, does that make sense? Okay. So then you can compare these two models side by side. You can look at the A and the B scenario, and you can zoom in the actual differences between those two scenarios, right? You can adjust it, you can change some of the parameters, and you can re-simulate it to make sure it's as accurate as possible, your simulation scenario. Okay, all right. So that's process mining in a nutshell, right? We're trying to get insight of our raw data. We're trying to do all types of analysis on the frequency, the conformance to an enterprise model. We'll look at the amount of rework and duration, and we're trying to figure out if there's any potential for automation. You've seen a couple of dashboards, but of course you can also create your own custom dashboards as well to zoom in a certain function or to look at a specific business features, such as, for example, invoices without a purchase request, right? So those things can also be highlighted out of your data and be visualized into those diagrams. And of course, a simulation where you actually, we're trying to create a kind of a digital twin, right? A digital representation of your organization to figure out and to simulate the to-be future scenario if we would apply more automation to my organization, okay? Now, when we do process mining, we're doing more than just process mining. We also do what's called task mining. So task mining is a subset of process mining. And what we want to do here is to figure out, hey, the data that we have uncovered from our process and task mining, why don't we use that, right? Why don't we use the task mining data to actually kickstart our automation? So let me show you what that actually will look like. So task mining is a subset of process mining. I already told you the process mining looks at log file data and try to create a process, right? Task mining looks at people's individual desktops. We're looking at the individual desktop to actually figure out how much time people spend on certain tasks, how much time they do, idle time. Okay, so you have a recorder on people's desktop that actually records their actions. So we can actually use that recording to feed into RPAs. Okay, let me show you what it looks like. So what you're seeing here is the actual recorder. So this is where we define the scope of what we want to record, certain URLs that we want to capture, certain applications that we want to capture, right? Because of course we want to create reports of that later on as well. Okay, so what I'm going to do now is I'm going to start the recording, and then I'm going to be using my system, which is SAP, and I'm just going to do my daily work inside SAP. Okay. All right. So I'm just setting up SAP, and I'm going to start the recorder, and then I'm just going to do my day-to-day job. All right. So as I do my day-to-day job, I want to process any invoices. So I go to SAP, and I'm going to log in as myself, and I'm going to create a new purchase order. So I'm searching for the vendor, adding the information regarding the actual products and the items. Over here, the material that I want to order. It's searching for the materials. I can put in the quantities in SAP. Yep. And I'm going to order 300 of those, 3,000. And I'm going to save that order. So now SAP is going to come back to me with a specific number, right? A confirmation number. Standard purchase order created with the purchase order number. Okay. So let's say that's all I'm doing that day. So I'm going to stop the recorder. Okay. So now what's happening? So that task model is now being sent to the server. And you can do all type of analysis with that, of course. But in this case, we want to do a little bit more than just analysis. Okay, so we go back to our process mining tool. And we can look at the actual information that was being captured. And what we can do is we can pick an RPA vendor. You saw that there was two RPA vendors inside the list. IBM RPA. We also have UiPath. So we can actually create a skeleton script for IBM RPA or UiPath, right? So that's what we're trying to do. Because the task mining data has captured, of course, everything that we've clicked on. And the task mining data is also being visualized here, right? So it's been visualized inside our normal reporting screen. So very similar to process mining, a task mining model is visualized in the exact same way. So everything goes to a single shared repository between the two tools. Okay, but we can go one step further. We go to task mining, and we're going to be generating the actual RPA scripts. Before we do that, of course, we can still, of course, also simulate that process. Let's play with the RPA candidates model. See how much money we will be saving if we actually apply automation to it as well. You've just seen that before as well, right? We can do the gap analysis. Like I said, you've seen it before. So I'm just going to skip over that. But here's the magic button that says generate RPA bot. Okay, let's go up a little bit. So those were the two scenarios that were being that we actually are comparing to each other. But here we say generate RPA bot. So it's doing that from the task mining data. So when we click on it, we'll actually download a file. It will download the actual RPA skeleton file. And then when we move to RPA, we can actually import that skeleton file into our RPA tool. So this is what you're looking at now. This is IBM RPA. So this is IBM RPA, and right now we're looking at the diagram overview where we have the different tasks segmented. Let's load it in the scripts. And then we actually have the individual activities, right? We have here the individual activities here in the middle of our palette. Link it to that file. And then we can just simply play, right? We can, of course, adjust it to do something more complicated. But in this case, we're just going to replay what we have captured. In this case, it's going to do something in SAP. It's going to create the purchase order. And you can see that the RPA bot works really, really fast. And boom, the purchase order has already been created. So an RPA bot is much faster, of course, than a human. It will process the task as soon as it's able to refresh the screen. That's how fast you can actually process that order. So we just automated entering a purchase order using the RPA bot by linking the recording from process mining into RPA as a skeleton script. Okay, so that's what we have done so far. Right. So the whole point of RPA, right, is really that we're trying to reduce human error. If we're doing boring things like entering data, copy pasting things, we're gonna make mistakes. People always make mistakes. And a lot of times our project, it's not big enough. It's not big enough for a full-blown automation project. So that's why we can use RPA as, I wouldn't call it a Band-Aid, but I would say it's a stopgap solution. right? It's for those projects that are not complicated enough, that do not have enough budget for full automation. For those projects, I think RPA is a great solution to quickly get automation going, to quickly reduce the amount of human work, and to accelerate the time that we can actually stand up a new application and automate tasks, which are typically be done manually, right? So in order to do that, we have a certain amount of bots. We have the attended bots and unattended bots. So attended bots are almost like virtual assistants, which you kick off yourself as a user. An unattended bot sits in the basement and it reacts to events. And of course, we also have chatbots as well, of voice recognition systems that we can configure into our platform, which is quite unique to our platform, right? So it can interact with systems, it can read documents, it can communicate, it can create documents, can process files, it can use your Windows operating systems, it can interact with your browser, keystrokes, green screens, anything. So a bot is like a virtual worker on the desktop. So the way that you author it, you've just quickly seen it already. We're using drag and drop. So this is not coding, what you see here. What you see here is a list of commands that are being dragged from the left-hand side. On the left-hand side, you see a bunch of commands to like clicking on Windows, get data from a database. You just drag them into the middle, and then you configure that specific command using a wizard screen. Okay. We are also able to do OCR and extract data from incoming documents or PDF files or TIFF files to actually read what is happening inside that image. And like I said, unique to the IBM solution is a chatbot instance as well. And this is where people can use that interface to actually have some Q&A with your organization, right? So that your phone lines are not overloaded, with typical questions from your client base. Some AI capabilities that exist in there, like I said, OCR, classification of the type of content. We can read structured and unstructured data from incoming messages, email or SMS. We've got a bit of fuzzy logic when it comes to decision making as well. And we can also do statistical analysis. These are all built into the platform itself. As a manager, of course, you want to have dashboards and reports to figure out how your bots are performing and if they are still running on time and if none of them have failed over. Okay. And the service automatically distributes the work across your several bots. So every time you have a new task coming in, the service says, hey, there are 10 desktops available. Let me assign it to desktop 1 and then desktop 2 and then desktop 3. So it automatically distributes the work amongst the available desktops. Now, what is really cool, and this is a summary slide, but what's a really cool, unique feature is what we call concurrent execution. So concurrent execution is the ability to run multiple bots on the same hardware. Now think about it for a while. Normally when you have a bot takes over your entire desktop, right? So you need to buy a Windows license, you need to have a virtual machine for each bot. So one bot is one virtual machine. 100 bots is 100 virtual machines, but not with IBM. In IBM, you can run 15 bots on the same machine. So instead of having 100 virtual machines, you only need like 6 or 7. So you already have a massive cost savings when it comes to infrastructure if you roll out IBM RPA. Because we're the only one that has proper concurrent execution, multiple bots running at exactly the same time on a single piece of hardware. So the cost of actually owning IBM RPA is by far the lowest in the entire market. Okay. So I've come to the end of the formal section of the presentation. I wanted to open the lines and see if there's any questions so far. Any questions using have any questions come through the chat? Or of course, you can also unmute yourself and ask a question.
Thank you, Philip. I think there are a few questions in the chat window. Let me take it one by one. So first question is, how does RPA differ from traditional automation?
How does RPA differ from traditional automation? I think I mentioned it very briefly. RPA, I would say, is really a shortcut. All right. So how do you normally do automation? You're trying to do integration, right? I need to hook up this database, or I need to hook up some data from this application, copy that data field, and then put in that application. So you need to do messaging. You need to look at the database, or you need to do some web service call or REST call to get the data from application 1 and put in application 2. But RPA, you just record your steps. You say, copy this field and paste in there. You're doing integration through the glass by simply clicking on the buttons instead of going through the back end. So it's a much faster way of doing integration, because you don't need to know the actual data structure. You don't even need a programmer. You could just teach the bot, click here, read that, copy, and then paste that other application. So that's why RPA is a much faster way of getting automation done.
Okay, thank you. Second question we have is, can process mining be used for real-time monitoring of processes?
Yes, to a certain extent. Now, what I mean with that is the process mining dashboards can be hooked up to APIs. So it can actually get data on a regular basis from those sources to update its dashboards. So it is possible. However, it's really not the intent. The intent of process mining is to be used as an analytics tool, not as a dashboard. So even though it's technically possible, it's really not the intent of process mining software to be used as a operational dashboard.
Okay, thank you. Can RPA extract insights from unstructured data sources such as email, documents, and social media content?
Yes. So this really depends on, I wouldn't say it really depends, but it is definitely possible. And there's two ways of doing it. First, you can use the native AI capabilities that exist in IBM RPA, or you can use RPA to trigger a dedicated OCR application, or a dedicated language understanding tool. So there's two ways of doing that. But yes, it is definitely possible.